Hi, my name is Daniel Armin, and for this project I chose Michael Faraday. He was born on September 22nd, 1791, and this project is done by Daniel Armin. Scientist Michael Faraday. He was born on September 22nd, 1791. The digits I managed to obtain from his birthday would be 9 for his birth month, 2 and 2 for his birthday, and 1791 for his birth year, giving me f of x equals 9x to the 6th power plus 2x to the 5th power minus 2x to the 4th power minus x to the 3rd power minus 7x to the 2nd power plus 9x to the 1st power plus 1. So for a quick understanding of Michael Faraday, he discovered diamagnetism, which is a quantum mechanical effect that occurs in all materials causing repulsive force. He also discovered benzene, which is a highly flammable chemical, and he also discovered electrolysis, which is being able to remove any unwanted effects on your body. So if you look at the quick graph on the right, you can see 3 turning points, a y-intercept, zeros, and a minimum turn, which is also the turning point. I'll explain these later in the summary. Table of values. In the table, wherever x may fall within the graph, the y-axis will meet in the x-axis. If you take a look, 2 and 591 in the x and y values, and look at the photograph, you can see it on the right-hand side. And if you look at -2 and 443, you can see it's on the left-hand side, showing that there is a positive curvature as it's also unproportional. So the zeros are -1.205, 0, and -0.103. So I kept on going with this to find it. And I used the graphing calculator. Characteristics. To find the y-intercept, I plugged in 0 for all of the x's, canceling everything out, giving me y equals 0, 1. The leading coefficient is 9 because it's the highest number with the highest exponent, and the degree is 6 because it's the highest degree. All real numbers, zeros, roots. Finding all real numbers that were in the graph were fairly easy because all real numbers lie on the x-axis with no y-intercept. So I got -1.205, 0, and -0.103, 0. You can use a graphing calculator to find this. All local turning points in the graph, finding using the table of values. So if you take a look at the table of values, you can notice a drastic change as in the unproportion. If you take a look at -2 in the x value and 2 in the x value, you can notice that 443 and 591 are drastic, as you can notice an immediate shift in the positivity as it goes up. So the turning points are -0.897, -9.752, and 0.595, 3.964, and 0.435, 3.529. And behavior. Using the leading coefficient test, I managed to observe that the exponent is even, meaning one of the side rises, and the leading coefficient is positive, being 9, meaning both side rises. As you can see in the graph, the left side rises immediately, and on the right side has a sharp curve, and then goes up as well. Theoretical zeros using the graph. In the graph, using p over q, p being the constant and q being the leading coefficient, p would be 1 on the right side being the constant, 1. Q is 9 being the leading coefficient being on the left side. So as we're considering possible zeros, it would be positive or negative. So to get positive -1 for the constant, positive -1/3, and positive -1/9 for the p over q. However, the real zeros would be -1.205 and -0.103. A different method would be to find the highest exponent, which would be 6. So there are 6 possible theoretical zeros in the graph. Theoretical turning points on the graph. There would be 5 theoretical turning points, as using the formula n-1 and plugging in 6 for it would be 6 minus 1, giving 5. In actuality, it only is 3. The minimum of the graph and the changes in the shape of the function. The summary. So the minimum point is also a turning point, being -0.897, -9.752. The roots are -1.205, 0, and -0.103, 0. As I said, the minimum is one of the turning points, and the other ones are 0.593, 3.964, and 0.435, 3.529. And the y-intercept is 0, 1, as you can see over here. Reflecting on the scientist Michael Faraday. Michael Faraday and his graph relate to each other as his study in electricity impacted the way we survive, now by his theory of light, suggesting that electromagnetism was connected to light, coming from his discovery of realizing that a magnetic field influenced polarized light. This phenomenon became known as the Faraday effect and has contributed to many scientists expanding his ideas, and the curve in the function curves positively and opens up. His beneficial ideas support the graph as it opens up, and as the graph is positive, as were his ideas. As you can see, this on the upper right hand side is one of his inventions, and this curve right here kind of relates to the graph.